Okay, going back to lists. Now I'd like to bring your attention back to this slide from the strings module. Remember that you can use a for loop to go through a string one character at a time. Lo and behold, you can do the same thing with lists. In this example, we have a list called L, and we create a variable called item in a for loop that gets set to each thing in L in succession. Incidentally, you can also do this with tuples. Let's say we have a list of the names of people waiting in line for something. We want to print each name along with that person's position in line. With this kind of loop, we can't because we don't have access to what index we're on inside the for loop. We could write a for loop the old-fashioned way using range, len, and I, but Python actually has a cleaner way to do this. And it's the enumerate function. Take a look at the for loop in the upper right and notice a couple things. First, the list names is now put in a call to this new function called enumerate. Second, there are now two variables, I and name, separated by a comma after the word for. This basically acts like two for loops at once, one which creates the variable I and assigns it each possible index from 0 to 2, and one which creates the variable name and assigns it each name in the list, Rita, then Mo, then Maya. When I is 0, name is Rita. When I is 1, name is Mo, and when I is 2, name is Maya. We now have both the variables we need in order to print a numbered list. And if we want our numbered list to start at 1 instead of 0, we can just add 1 to I before giving it to the stir function. The last thing I want to talk about is what you can and can't do when you have a list that contains a tuple and when you have a tuple that contains a list. Let's start with the case where you have a list that contains a tuple. Remember, lists are mutable and tuples are immutable. So what can you do with this list? Changing the element at index 0 in my list shouldn't be a problem. Lists are mutable, and this doesn't interfere with the immutability of the tuple in the list. Turns out this is fine too. Assigning to index 2 of my list swaps out the tuple, 3, 4, for the tuple 4, 5. Remember that immutable things cannot be changed, but they can be replaced. Here's where we get into trouble. We access the thing at index 2 in my list, which is now the tuple 4, 5. We then try to set the thing at index 0 in that tuple to 40. This is not allowed because this constitutes changing a tuple, which is against the rules. Okay, now let's do a switcheroo and make this program have a tuple that contains a list. This case is a little trickier to understand. Obviously, this gets us in trouble. We can't change the thing at index 0 in my tuple. For the same reason, trying to swap out the list at index 2 gets us in trouble. Okay, here's the weird thing. If we change something in the list at index 2, that's perfectly fine. You can think of this as an operation that just isn't within the jurisdiction of the tuple. The tuple is strict about not allowing its elements to be changed to other elements. But if something happens within one of its elements, like the list at index 2 in this example, the tuple doesn't notice.